Assalamu alaikum wa rahmatullahi wa barakatuh. Grade 9. Hello, how are you? Okay, today's session is the second session in our revision, inshallah. Last session we have covered the second part of physics, which is vector and vector operation, lesson 3 and lesson 4. And in today's video or in today's session, inshallah, we're gonna cover the first lesson and second lesson, which is acceleration and free fall acceleration. So today's session is all about acceleration. I think this topic is not a new topic for you. I know that you have studied that before or you have taken this before in the last quarter, but we have to get it from scratch. Okay, so what does it mean by acceleration, or when we can say that this car under acceleration, or this car in accelerating motion, or this car in decelerating motion? So what I mean by all of these sentences. So if we have a car just like this one, okay, so and this car is moving with velocity about 100 kilometer per hour. Okay, so if this car is still moving with this velocity, there is no acceleration. Why is that? Because this car isn't changing its speed. It's moving with a constant velocity or with a constant speed. Okay, so that means that there is no acceleration in this situation. Because acceleration means what? Changing any speed. So if this car tries to change its speed, if the driver push on the fuel or push more to increase its speed or to increase its velocity into 150 kilometer per hour. Okay, so in this time there is acceleration and the speed is, or the velocity is increasing. But this increase in the speed or this change in the speed doesn't occur in no time. It occurs in specific time or in certain time. So in order to change your speed from 100 km per hour to 150 km per hour, you have to take a time. And this time will be just like about 5 seconds, 10 seconds. Let's write it 10 seconds, okay? So, in order to say that we have acceleration, so we have to say that the velocity is changing. So the acceleration is the change of speed or velocity. Okay, and as we said that this change has taken a time, so over a time, or the change of velocity with respect to the time or in certain time. Okay, so let's make a rule for this physical quantity, which is the acceleration. So acceleration, we will give it the symbol A. Okay, and change of the velocity, change of means delta, velocity means v, divided time. So this change in the velocity has occurred in certain time. So here we have the time. Okay, and then we can say that the change of any physical quantity means the final minus the initial. So the final velocity, v final, minus v initial, divided time. So what does it mean by final or initial velocity? Final velocity means the velocity that the car gets to, or the initial velocity means the starting velocity, the velocity that the car started with. So this car started with 100 and reached to 100. From means v initial to v final. So if we just like to solve or to get the acceleration of this situation, we will say that the v final, instead of v final, we're gonna put 150 minus, instead of v initial, we're gonna put 100 And what about the time? Could we say it's 10 seconds? In real, the time is 10 seconds. But we can't use second. Why? Because here in the velocity have hour, and here also we have hour. So we have to make the unit is the same unit. That you have to use the same unit during using any rule. Okay, so right now we have to change from seconds to hours. How you can? So as you know that hour consists of 60 minutes. Okay, and minute consists of 60 seconds. So from this to this, time is 60. And from minute to second, time is 60. And from hour to second, as a one step, 60 times 60. And 60 times 60 means 3,600. So in order to convert from hours to second, you have to multiply times 3,600. For example, 5 hours consists of, or say 10 hour. 10 hour consists of what? So 10 times 3,600 is gonna be 36,000 in the 10 hour. If 10 hour consists of 3,600, 36,000 seconds. Okay, so let's get to convert from the smaller one to the larger one, like this one. You know that the second is the smaller one, and from the smaller one to the larger, we make division. So if you have just like this example, 10 seconds, and you want to convert them into 10 into hours. So you have to divide this 10 divided by 3,600. 3,600. Okay? Okay, that's fine. So the time will be 10 divided 3,600. Or we can make it by our calculator. 3,000 or 10 divided 3,600. It equals 0.0027. So we can erase this and write 0.0027. Okay? And that's it. So the final answer will be 50 divided 0.0027, which is equal 18.5. With which unit? So the acceleration is equal or is always with which unit? I know that we have taken this before, but I'm gonna make it very fast. You know, we get any unit from the rule, and the rule was delta V over delta T, and the V velocity with kilometer per hour or meter per second. So I'm gonna write here kilometer per hour and the time per hour. So kilometer per hour divided hour per hour means hour square. So the unit will be kilometer per hour square. So we have to write here kilometer per hour square. Okay? I think it's a little bit obvious, no problem until this moment. Okay, so far so good. So, because you are old, you are not so young to ask as a direct question as acceleration, what's the acceleration? So the question will be a little bit harder. So he may ask you about the V final, or he may ask you about the delta T. How we can get rule how we can get rule for time or for V final without memorizing any rule? Just use the changing parts. So A equal V final minus V initial over T. So in order to get the T, you can just exchange the place of these two. Why? Why you just like to exchange? Because this one here by the division, so it can transfer here by the times, and this one here by the times, it can change or move here by the division. So the time will be just like this. Time is equal v final minus v initial over acceleration. And this is the first derivative of this rule. Okay, so we have many rules we can get from the same rule. And I know that there is a lot of students are making this by the magical triangle. They always put at the numerator here the numerator of this rule. So the numerator here is v final minus v initial, and here we have time and we have acceleration. So in order to get the time, so the time will be v final minus v initial over acceleration, which is this rule. Okay, make it whatever you like. Second one, if you just like to get the v final, this one or this one, okay, how we can get this one? Okay, keep this rule or keep this in your mind. Whenever you like any physical quantity in rule, keep it in its place. So we're gonna keep the v final in its place and move all the physical quantities into the other side. So we're gonna move this one and this one. In order to move the time, you know that v final divided by the time. So because it's here by the division, it move here by the times. So it will be a times t. And this v initial or initial velocity here by the minus or by the negative sign. So it exchange its place or it moved to the other side with the opposite sign. So from here to get here, it will be by positive. So a times t plus v initial, all of this is equal v final. Okay, this one by division, get here by the times. This one by minus or by the negative sign, get here by the positive sign. Okay, so we get from this rule, which is v final minus v initial over t, the acceleration, we get two rules. This is the first one and this is the second one. First and second. Okay, so now let's just solve some problems on these very simple rules. So we can erase this one. Okay, let's get the first one. The problem is saying bus comes to sudden stop to avoid hitting a dog. Okay, and because it comes to stop means that the v final, the final velocity equal 0. And if you're not, or if you don't know why it's 0, because whenever you stop, the last velocity you get to is the 0. Okay, and then it accelerates. It was accelerating with velocity, or no, sorry, was acceleration negative 4.1. Acceleration was negative 4.1. And you have to keep this sign. Don't remove the sign. Meter per second square. Okay? Okay, so as it slowed down from 9 to 0, so from means v initial. V initial is equal 9 meter per second. Okay? Okay, so find the time interval of acceleration for this bus. He asking about the time. How we can get the time? We said from this rule we can get the time just like this. Time is equal v final minus v initial over a. So we're gonna write here time. You have to write the rule in any problem before you solve it, and then to make a substitution. V final is equal 0 minus v initial is equal 9 over acceleration is equal negative 4.1. Okay? and the answer will be with seconds. Okay, whatever the answer, it will be with seconds. Okay, and this example from your book, this is the first example in your book. Okay, let's get to the second one. Second one is saying a car traveling at 7 meters per second. So that means the V initial is equal 7 meters per second, and it accelerates uniformly at 2.5 meters per second square. Acceleration is equal 2.5 meters per second square to reach to speed of 12. So V final is equal 12 meters per second. Okay, so how long does it take for this acceleration to occur? How long does it take? How long means what? Means also time. He's asking about also time. So, and keep this in your consideration, okay? That how long means that he's asking about time or delta t. How far? So he's asking about the distance or the displacement, which is x. How many meters? So he's asking about the displacement. How many time or how much time? So he's asking about the delta t. So let's get here. The time with this rule, V final minus V initial. V final is equal 12. So 12 minus V initial is equal 7 divided the acceleration, which is 2.5, and we will get also the time with second this time. Okay, any problem? Let's get to the next step or to the next information about the acceleration. Before we go to the next point, I just like to say something in the convergence between the units. You know that you can describe the acceleration in meter per second square, or you can describe it by kilometer or kilometer per hour square. So if he asking how to convert from this one to this one, okay, so in abbreviation you can make a division 5/18, and from this to this one make a multiplication 5/18. So from the smaller one to the larger one, division 5/18, or from the larger to the smaller 5/18. So how we can get this 5/18? Because from kilometer to meter it's 1000, okay, and from hour to second, okay, from hour square to second square, it's gonna be 3600, okay, square. So you'll find the answer will be 5/18. Okay, that's fine. As we said that acceleration is vector in the last one of the examples of the vectors. We know many vectors like force, like average velocity, like displacement, and one of these vectors was the acceleration. That means that this acceleration need magnitude and direction. So let's know something about the direction of the acceleration. So how we can get the direction of acceleration? Any acceleration, any car, to make acceleration, to increase its speed, need a force, need a pushing force, or need any force to push this car forward or backward. Okay, so if this one or if this person trying to push this car in this direction, we know that this direction is east, and the east is always positive, and north is also positive, but the south and the west is negative. Okay, so the acceleration here will be in the positive. Okay, and what if this car already was moving with velocity before increasing the speed? I mean before this one exists here. Okay, so this car was moving in the same direction, was moving to the east. So here the velocity was in the east, so it's positive velocity. And the acceleration, when this one get here, he tried to push the car in the same direction. So the acceleration is also positive. So tell me, is this car gonna increase its speed or decreases its speed? Because both of them in the same direction. The velocity is positive and the one who pushed the car was in the same direction. So that means what? That means that this car is gonna increase its speed. Okay? So what if the car was moving in the positive direction like this, and this one was just like Hercules and was trying to pushing this car in the opposite direction. Car coming to his face and he trying to push this car in the opposite direction. So what does it mean by that? He gonna decrease the speed of this car, because when the acceleration is negative and the velocity is positive, the velocity is gonna increase. Or not the velocity, we can say the velocity, or we can say the motion. The motion is gonna decrease. Okay? So what if both of them were at the negative direction? The car was moving like this, and also the person who pushing this car was the same direction, in this direction. So both of them are negative, and negative times negative or minus times minus is positive. So the speed is also increased. So why it's increased? Because both of them are pushing at the same time, or the car already is moving in the west direction and this one is pushing in at the west. So the speed will be increased, but in the west direction. Okay? So in order to know the motion of this car, is it increasing its motion, or is it increasing motion or decreasing motion, you have to know the sign of the velocity or initial velocity and acceleration. Okay, and if the acceleration is negative, that doesn't mean that this is decreasing their speed, because I know a lot of students are doing that in the exams. Whenever he see negative acceleration, he shows the speed or the velocity is decreasing. Okay, so you have to make this equation before you decided it's decreasing or increasing. Take the acceleration times the velocity, and if it was positive, that means that this is increasing its speed, and if it was negative sign, so that means that this car decreasing its speed. Okay? Okay, let's get to the second one. How to make a graph for the acceleration. Okay? Acceleration, you said that the acceleration is equal delta V over delta T. So the graph will be just like this. Delta V here in the x-axis, and delta T here, delta V in the y-axis with delta T in the x-axis. Okay? So if the slope was just like this, that means what? That means that this car increasing its speed. This car moving with uniform acceleration. There is an acceleration here. So why there is an acceleration? Because here the velocity was 0, and then was, for example, 10, then 20, then 30. So what does it mean? That means that this car increasing its speed. Okay? But after a while, you find the slope just like this. What does it mean by that? The slope like this. So after time, for example, here was 1 minute, 2 minutes, 3 minutes, 4 minutes. So from the minute number 2 to the minute number 5 here, the car still moving with speed 30 meter per second or 30 kilometer per hour, whatever it was. So that means that the car moving with a constant velocity. The car isn't accelerate. Okay? So what does it mean by this? So the car here is increasing its speed or decreasing its speed. Just observe or just see the change happen, how the change this happened. The car accelerated, the car velocity was 30, and after time the car velocity became 20 and then became 10. So that means what? That means that this car decreasing its speed. So when the car decreasing its speed, so that means that this car is slowing down. Okay, so next one, what if the velocity, or what if the slope was just like this? Okay, if you get the speed, or if you get here the slope, you will say from this point to this point 30. Okay, this is a V initial, and the V final here مثلا is about 10 اهي, about 10. So 10 minus 30 divided, for example, 4 seconds. Okay, so 10 minus 30 is equal minus 20 divided 40 divided 4, so it's equal negative 5. So the acceleration here with negative direction, and it's with negative direction. Okay, so what does it mean that the acceleration with negative direction? Does it mean that it's slowing down or not? Okay, the acceleration with negative direction, yes, but the velocity was what? Was positive, 30, 20, V initial was with the positive, so the velocity was positive and the acceleration was negative, so positive times negative, that means that it's decreasing its speed. Okay, so let's get to this slope or this line. In this line, as you see كده, the velocity here was 0 and then was negative 10, negative 20, negative 30, etc. So at the first minute it was negative 10 and then becomes 20, but by the negative sign, and then becomes 30 by the negative sign. Okay, so in order to get the acceleration, you will say 30 V final 30 or negative 30 minus negative 10 over the time, and the time here was 4. Okay, so over 4, so negative 30 minus minus, which is mean positive, so we can change this one into positive. So negative 30 plus 10 equal negative 30 plus 10 equal negative 20. Okay, negative 20, and 10 minus 30. Okay, 10 minus 30 is negative 20 also. Okay, so let's get here. So negative 20 over 4. So the acceleration here negative 5. Okay, but the V initial is also negative. V initial is negative, and negative times negative is positive. That means that the acceleration is, or this car is increasing its speed. Okay, this car is increasing its speed. Okay, okay, but in the opposite direction. Okay. Let's get to the second part. Okay, motion equations. Motion equations is to know the distance during this acceleration. For example, you have a car. This car is increasing its speed from 100 to 150. Okay, and in certain time, say 10. Okay, and during this motion, or during increasing its speed from 100 to 150, it takes certain distance, or it takes certain displacement. During you increasing the speed, your car covered the distance. How you can get this distance, or how you can get this displacement? You can get it by the motion equation. So most of motion equation is to get the x, or you can get also the V final by using the x. Okay, so let's get the first equation. The first equation is always comes from the average velocity. The average velocity, what does it mean by average velocity? We said before, to get the average velocity, here مثلا we have a car moved by 10 مثلا moved 10 meter in 3 seconds, and then 15 meter in 2 seconds, and then مثلا 5 meter in 3 seconds or in 4 seconds. So how you can get the average velocity? To get the average velocity, we take the total distance, or the total, yes, total displacement or total distance divided total time. Where is the total distance? So 10 plus 15 plus 5. Or where is the total displacement? This part, the total displacement. So we can get the total displacement divided the total time. By this, you can get the average velocity. So the average velocity is equal delta x over delta t. And at the same time, if you have a car moving from, for example, from 100 kilometer per hour at the beginning of its journey to 200 kilometer per hour. What I mean by that? Car was moving with 100 and then increasing its speed to 200. So the average velocity in this journey is equal what? The average velocity is gonna be 150. It's a number between 100 and 200. This is the average, right? How we get this one, or how we get 150? You said that V initial, which is 100, plus V final, which is 200, divided 2. So it's gonna be 150. Okay, so the second rule for the average velocity is V initial plus V final over T, or over, sorry, 2. So in order to get the delta x, you will say what? You will say delta x is equal this one times this one divided this one. So you can say delta t times V initial plus V final over 2. And this is the first equation, or this is the first motion equation. Let's get to the second motion equation. Okay, second motion equation, we have a proof for this, and we also mentioned that in your class. Okay, but now we don't have the time, we make a revision, so we don't have to get the proof, the total proof right now. We just know, or we just like to get the equation itself. We said abbreviation to memorize this. To be vet, have your at. Okay? Just like a fit. To be vet, V initial, delta t, يبقى vet, half at square. What I mean by that, vet V initial, t, delta t, or change in the time, half times acceleration times time square. And this is the second motion equation. The second one. Let's get to the third one. Do you remember when we get the V final? From the acceleration we get the V final. So V final was, or acceleration was V final minus V initial over delta t. How we can get the V final? I moved this one to here by the times and this one to here by the plus. So the V final was equal A times delta t plus V initial. The V final is also so similar to this equation, but instead of V final we write V final square, and instead of V initial we write V initial square. And because this equation is required to get the acceleration or the V final or V initial without using the time, so we can't use the time here. So replace this time with acceleration, replace this time with displacement. So we're gonna put 2a delta x over x, and this is the third equation. Okay, the same like this. Instead of V final we put V final square, instead of V initial we put V initial square, and here in this step we also put 2, but not in the power. 2 times acceleration, and instead of the time we use the displacement, because this equation we use whenever we don't have the time. Okay, and this is the third motion equation. So here you have to know when we can use the first one, and when we can use the second one, and when we can use the third one. The first one is we always use it when we don't have acceleration or we have the V final. And you can get from this one delta T, V initial, مثلا displacement, all of these you can get it. X, second one, you can use it if you don't have the V final but you have the acceleration. And last one, you use it whenever you don't have the time. So if you don't have time, okay, that's fine. Okay, let's try to solve some equation or some problems in these three motion equations. Okay, so I'll erase this part, don't need, and this part also, but I'm gonna leave the equation because we're gonna use them. Okay, first problem is saying car accelerates uniformly from rest, so that means that V initial is equal 0. To speed 6.6 meter per second, V final equals 6.6 meter per second. In 6.5 second, time 6.5 second, okay? And then find the distance that the car travel. So find the distance, he means he just like to get the x. So which x we can use? We have two x, this one and this one. Okay, let's try to choose between them. I need the equation consists of V initial, V final, and T. V initial, V final, and T. So all of them are exist. But here I don't have the acceleration. Yes, I know I can get it, but it's gonna take another step to get the acceleration before you use this one. So we can use this one in one step. So I'm gonna use this one. So I say x equal delta t, t is equal 6.5 times V initial is equal 0 plus V final 6.5 divided 2, okay, and this is easy. And because here the velocity was with meter per second, so we're gonna use the unit meter with the displacement, okay? This fine? Okay, so you can make it by your calculator. Let's get to the second one. He's saying, okay, we have a car or we have a driver applies the brake, okay, of her car. The car slows uniformly from 15 to 0, from V initial to V final, from 15 to 0, meter per second. And then how many meters? So he asking about the displacement. How many meters before a stop sign must she apply her brakes? And okay, he changed its velocity in time 2.5. The time was 2.5. Okay, so to get the x, all we're gonna do is to use what? Use this equation. Why we don't use this equation? Because we don't have the a, so we can use this equation very easily. So 2.5, which is the time, times V initial equals 0, V initial equal 15 plus 0 over delta over 2. Okay, so the answer will be whatever it was, but it's gonna be with the meter unit because here the velocity was by meter. Okay, so let's get to the next one. Okay, he's saying the first flight around the globe without single refueling was completed. The aircraft average speed was 186 km per hour. Danny, the average speed was, so the V is equal 186 kilometer per hour. Okay, if the airplane landed at this speed, okay, and accelerate by negative 1.5 meter per second. So it landed by the same speed, landed means comes to the ground, okay, and then made the decelerating motion with acceleration, or decreased their speed with acceleration a equal negative 1.5. Okay, how long did it take for the airplane to stop? How long did it take, okay, to stop? So he started with this speed, so this is V initial, and you have to know how long does it take to stop. Means stop, that it's gonna go to the final velocity, or it's gonna get to the stop, which means the final velocity is equal 0. And we have the acceleration. And he asking about how long did it take. So he is asking about the time. Okay? And here we have variety of choices. You can get the time by this one, or you can get the time from the acceleration. Which one? You know that the acceleration is equal V final minus V initial divided delta t. And in order to get the t, we exchange between those. So the delta t is equal V final minus V initial over acceleration. Okay? But also you can use this one, and by shift solve you can get the delta t. But this one is easier here, so we're gonna use this one. So I'm gonna say delta t is equal V final 0 minus V initial 186 divided, okay, divided what? Here we have something very important. What this one? Okay, I just like to exchange some part because I just did something wrong in the conversion. I was saying if you just like to convert between the speed by the kilometer, because the speed is kilometer per hour, to meter per second. Okay, and I was there converting between kilometer per hour square to kilometer per second square. No, I mean by 5 times 18 is to convert it from this one to this one. Okay, let's forget this one. Now we have acceleration, but this acceleration with which unit? This acceleration with meter per second. Okay, so this one by meter per second. And we have here initial velocity with kilometer per hour. So, and he didn't mention, he just like to get the time in seconds or in hours. So we can use we can get the time in seconds. Okay, so how we can get the time? We have to make all the units that we're gonna use in the same unit. The acceleration meter per second, but here the velocity kilometer per hour. So we can change this one from kilometer per hour into meter per second. How we can make that? We can make this by taking this one times 5 over 18. Okay, so 186 times 5 over 18. So it's gonna be okay. Okay, it's equal 50.22. Instead of kilometer per hour, we're gonna say, or we're gonna write meter per second. Okay, so 5 divided 18. Okay, that's fine. So let's change this one into 50.22. Okay, and the acceleration here, because here is the acceleration is already by meter per second, square, so we can write negative or minus 1.5, and the answer will be 33.48. Okay, that's fine. So the time will be with second. Okay, if anyone of you doesn't understand this, I'll try to say it again. We have the V initial and the V final and the acceleration. Okay, so the V final here with kilometer per hour and the acceleration with meter per second. And we said whenever we use any rule, we have to make the same, or we have to use the same units. So I used meter per second here. So I have to convert this velocity to meter per second. How you can convert the velocity from kilometer per hour to meter per second? From the larger to the smaller. So times 5/18, we get 50.22. And then I just applied the rule here, or substitute in this rule. This rule is saying V final equals 0 minus V initial equal 50.22 divided acceleration is equal negative 1.5, and we get this final answer by the second, because all of the unit here by second, so we get the time by the second. Okay, I hope it's understood. Okay, let's take another one. And car or an automobile with initial velocity 4.30 meter per second. Okay, accelerate uniformly at rate of 3 meter per second. The acceleration is equal 3 meter per second square. And then find the speed and the displacement after 5 seconds. He asking about two variables. He need to get the displacement and also to find the speed, the final and the displacement. After 5 seconds means the time is equal 5 seconds. Okay, so at the first, if you just like to get the x at the beginning, you have to use this rule. Why? Because you don't have the v final, so you can get the x by this rule because you don't have the v final. So let's use it. Okay, I'm using this rule. Okay, V initial is equal, I'll say V initial 4.30 times delta t 5 plus half times A 3 times t squared 5 squared. Okay, and because this one is by meter per second, so the displacement will be by meters. Okay, and then we have to get what? And then we have to get he asked about the displacement and also about the V final. Let's get the V final. V final, we have here V initial and V and T and A. So we can get the V final by this rule, any rule from this, or we can get it by the old rule from here. V final is equal this one. V final is equal delta t times A, or A times delta t times this one by plus V initial. Okay, so V final is equal A 3, okay, times delta t 5 plus V initial 4.30. Okay, and because this is V final, so the answer will be meter per second. Okay, I hope it's understood. So let's read this one and to get to the final one. Okay, find the velocity after. Okay, we have stroller. You know the stroller is a baby car. A person who's pushing this stroller, okay, from the rest. So V initial is equal 0. Okay, uniformly accelerating at rate of 0.500. So acceleration is equal 0.500 meter per second square. What the velocity of the stroller after it has traveled 4.75? After has traveled 4.75 meter. Okay, so he's asking here about what? He's asking about the final velocity. The velocity after is always final velocity. Okay, do we have the time? No, we don't. And we said if you don't have the time, use this rule. So we're gonna use this one. Okay, so v final square is equal to ax plus v initial square. Okay, v final square equal 2 times a is 0.500 times x is equal 4.75 plus v initial 0 square. Easy? But the answer will be not v final. The answer will be v final square. صح? So in order to cancel this power, what we can do to erase or to cancel this power, the operation to cancel this power is to put here root. And in order to put here in this term root, you have to put root also in this term to make it a real mathematical equation. Okay, this one gonna cancel this one, so we can erase both of them just like this, and we will get this. So by your calculator, you will just write in your calculator root 2 times 0.5 times 4.7 plus 0 square, which is 0 square, which is 0. Okay, that's set. We're gonna get the v final. The next question is saying find the velocity after the stroller in the sample problem E has traveled 6.32. It means what if the x was 6.32? So it's easy. We're gonna change or exchange the x from this value to this value. The x here was 4.75, so I'm gonna erase it and put instead of it 6.32. 6.32. Okay? Okay, easy. Okay, let's solve number 2. Or let's solve number 4, for example. Okay, maybe we get another new idea. He's saying a motor boat accelerates uniformly from velocity 6.5. V initial equals 6.5. 6.5 watt meter per second to the west. Okay, to the west. It's no idea. To the west. We said west here and east is here. So to the west means that this is by the negative. So don't forget to put the negative here. Even if he didn't write the negative at the velocity, and as long as he said to the west direction, you have to write negative before the value of the velocity. Then he said what? To the west, okay, to a velocity 1.5. So he was decelerating or decreasing its motion from velocity 6.5 to velocity 1.5. So v final is 1.5. Okay, but it's always, or it's also to the west, so it's also negative 1.5. Okay, if the acceleration was 2.7 meter per second square, so acceleration is equal to 2.7 meter per second square. Okay, then how far did it travel during the acceleration? He asking about how far, and we said how far he need the displacement. Okay, do you have the time? No, so we have to use this rule. Okay, but how I can use this rule? Okay, I'll write every physical quantity in its place. V final square, so negative 1.5 square equal 2 times acceleration. Acceleration is equal to 2.5, so 2.5. Displacement times displacement. I don't have the displacement, okay? So the displacement I'll write like this. D, the unknown. I don't have it, okay? Plus, plus V initial square. V initial negative 6.5 square. Okay? So what I can do to get this x? You have two solutions, or you have two ways. You can write the same equation on your calculator and then make shift solve, and you can get the x directly. And you also have another solution. What is the solution? After you writing this, you can get the x. How I can do that? Okay. To do this, all what you have to do is leaving what you need in its place and moving the other into the other direction, or into the other side. So what we have here, we have this one times this one, because these by the division, they're gonna come here by the these by the times gonna come here by the division. So the answer will be negative 1.52 divided 2 times 2.5. Okay, and this one with what? Positive or negative? Positive times negative is equal negative. So this one by the negative. So this one comes to the other side by positive. So plus 6.5 square. Or we can write it down here. Plus 6.5 square. Okay? And here you can get the x that you want. So the first solution is to make it by shift solve, and instead of the displacement you're gonna put x. Or you can move these variables to the other side. Here they are by the division, they get here by the, here by the times, they get here by the division. Okay, pause, get here by division. And this one was by minus or by negative signs, so it comes here by positive sign. Okay? And that was all about the first lesson. And I have a great news for you. The same equations that you used in the first lesson, you have to use in the second lesson. I'm not gonna give you another new rule or law. Okay? So all you have to know for the next lesson is about some abbreviation or some new names for the free fall acceleration. Just like what? Okay? I'm not gonna erase those equations, I'm just gonna erase the problem that I have solved. Okay. I'm gonna write here free fall acceleration. What I mean by that? Free fall acceleration. Free fall, something is falling like this. Okay? Something is falling down. Or something you have, or something you threw it up and then comes down like this. Threw it up and then comes down like this. Okay, so it comes up and then get down. Okay, let's take this one at the beginning. Okay, so if you have a marker like this one and then you leave it to fall down, you're gonna find, or you're gonna notice, its speed or its velocity is increasing. Okay, so its velocity is increasing. That means during the falling down, V increase. The magnitude of the V increase, but the direction isn't increase because it's down, and down means negative direction. So the V, negative V, increase. But if you throwing this ball up, or if you throwing this marker up just like this, during the journey of falling up or during the journey of throwing it up, means the velocity was increasing or decreasing? No, the velocity decrease. But at the same time, it has positive sign. So the velocity here with negative sign, but at the same time it increase. And the velocity here with positive sign, but at the same time it decrease. Okay? So what about the acceleration? The acceleration. Okay? As you know that we said before, the acceleration is taking the direction of the force. And where is the force here? There is a certain force try to grasp or try to pull this pole downward. What is its name? Its name is gravitational force. Okay? So the gravitational force the force that try to grasp or try to pull this pole downward. In both of the situation, if you just notice, the gravity is trying to push this down. Even the pole was already moving down, so the gravity is trying to move it down. And even the pole, if the pole is trying to get up or get very high, the gravity is trying to slow it down or to get it down. The proof for this one is after a while this pole comes to zero and then gets back because someone is trying or some force is trying to pull it down. So the force here is down and the force here is down. So the acceleration here is negative and the acceleration here is negative. The acceleration here is negative 9.81 and the acceleration here is negative 9.81. And because here the acceleration is in the y-axis or vertical, not horizontal, so and if is affected by the gravitational force, so we call it the gravitational acceleration or the free fall acceleration, AG. And also we can call this AG, means the free fall acceleration. Okay, and what's gonna change in these problems or in these equations? You said that we're gonna use the same equations. I'm right, I'm honest. But you just only gonna change the x into y. So why you gonna change the x to y? Because in the car motion is moving at the x direction. So whenever you like to get the displacement, you get the x or the delta x. But for this one, as you see, the poles comes down or the poles come up. So that was in the y direction. So if the car is moving down, so it comes down to the negative y direction. And if it was coming up, so it moving to the positive y direction. So I'm gonna put or write, instead of hx, I'm gonna write y. This is y, and this is y, and this is y. And instead of any a, I'm gonna write ag, and that's it. And I have to say some important notice or secret message for you, or secret notice. Without these notes or without these shortcuts, you will stop in your exam. Why? Most of the time he don't give you the acceleration and you will be so confused. Why? Where is the acceleration? Because the acceleration in Earth is always negative 9.81. So he don't have to give you the acceleration. You have to know that the acceleration is negative 9.81. So whenever you use any rule of this, right, the acceleration is negative 9.81 unless he changed the planet. And if he changed the planet, he gonna say that the acceleration is equal blah 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 blah. Okay? So you have to use the acceleration at this. You have to also use the v initial is 0, because whenever you threw a pole, okay, if you threw this pen just like this, so you threw this pen from 0, from velocity equals 0, and then you leave it, it start to increase its speed. So you start from 0, so because of that the V initial most of the time will be 0 unless he said the V initial or the starting velocity was كذا. Okay? So keep these secrets with you, don't forget them. If he didn't give you acceleration, so it's equal negative 9.81. If he didn't give you V initial, so the V initial is equal 0. And also don't forget, he will ask you about the V final or the final velocity. Don't say that he gonna come to the ground. So when this plane come to the ground, that means that the V final is 0. No, he asking about the V final or the final velocity before it hitting the ground. The last velocity it reaches before it hitting the ground. So don't say that the V final is equal 0 because it's gonna hit the ground. No, okay? But the V initial is equal 0 unless he say the V initial is equal certain number. Okay, let's solve problems. Let me check the videos. Okay, that's great. Okay. Okay, first one. A robot probe drops a camera off the rim. Okay, so we have a robot and we have a just like height like this, and this robot have a camera in his hand, just like this one camera. Okay, and he dropped this camera from height 239. Okay, this height is 239. Okay, then and this wasn't in Earth, this was in Mars. This was in Mars. So where the free fall acceleration is negative 3.7. So why here we didn't substitute the gravitational forces or the acceleration due to gravity negative 9.81? Because he said it's another planet, it's in Mars. So because of that, or in Mars, so because of that, the acceleration is equal negative 3.7 meter per second square. And this is called AG. Okay, so what he like to get, he find the velocity with which the camera hits the ground. The velocity here, V final, before it hit the ground. Okay, so without saying to me that the V initial is equal 0, I'm gonna write the V initial equal 0. But in real, he didn't mention that in the problem. Okay, and then we just like to get the V final. So is there any time? No, there is no time. Okay, how we can get anything without time? We use the secret equation that you use whenever you don't have the time. So I'm gonna write it down. 2AGY plus V initial square. And since, or as long as the V initial square is equal 0, so we can remove this part because this V is equal 0 and 0 square is 0. Okay, so V final will be, V final square will be 2 times AG times Y. And in order to remove this square, you have to put here square root. Yeah, V final is equal root 2, and AG is equal what? Negative times negative 3.7 times Y, which is the height, this is the Y, 239. Okay? Okay. To the negative direction because it's falling down. Okay? That's fine. But keep that in your consideration. If you have the acceleration with negative, and you try to make it with your calculator, you will find error because there is no negative root. So what should I do? Put the negative out of the root and then return it back. Yani for example, if we have here root negative 5, the calculator will say error. So how I can get the answer? Put the negative here. So say root negative, so negative root 5. So you will get the answer very easy, and you will put the negative before the root. Okay? Okay, that's fine. So V final will get it by meter per second, because all of the unit here with meter per second. Okay? And this was the first ask he asked us, or the first requirement, or the first. Let's get to the second one. Okay, then find the time required for it to hit the ground. Okay, the time, you can get it by any one of these, but we have another rule easier than this. Delta T is equal from the first rule. V final minus V initial over A. Us. And since we have the A was equal negative 3.7, and we get the V final from the last step, okay, and we also have the V initial with 0, so minus 0, so you're gonna get the delta T. Okay, so the V final from the equation that I wrote here. So you will find the delta T, and don't forget, delta T will not get, or will not be with negative signs. There is no time with negative sign. Okay? Okay. And it will be second. Okay? So find the V final from the last problem, or the last equation that we did, put it here over the acceleration and get the time. Okay, let's solve this one. Number 2, flower pot falls from window 25 meters. Okay, we have a window right here. This is window. Okay, and the height was from this window to the ground 25 meters. How fast is the flower pot moving when it strikes the ground? You need the V final. And also he's asking about how much time. He needs the time. So just like the last problem. Okay, the same, just like the last problem, but here in this problem he didn't give us the acceleration. And we said when he didn't give, or when he don't give you the acceleration, or when he doesn't give you the acceleration, so use the acceleration by negative 9.81. Okay, so let's get the V final. I said V final square equal blah blah blah. So to get the V final, only the V final without square, I'm gonna write root 2 times A negative 9.81 times Y. Y is 25, and here because it's moving downward, so it's negative 25. Okay, so that's fine. Next one, get the T, and we just said the T is equal V final, okay, minus V initial over A. V final from this, you will get the V final from this equation. Write the V final here, okay, and V initial is equal 0, and the acceleration will be negative 9.81. Okay, that's nice. And that was all about. Okay, let's take another one before we go. A tennis ball. Okay, tennis ball is thrown vertically upward with initial velocity 8. Okay, so tennis ball thrown upward, and the velocity was 8. Okay, meter per second, and then that's it. What will the ball speed when the pole speed will be when it returns to its starting point. You know that the pole is gonna get up and then get back to the same point. So he asking us, when this pole gets back to the same point, what is the speed or what is the velocity? The velocity will be also 8, but with the negative direction, because here the velocity was moving upward, so it's positive. But here when it gets back, so it's gonna be negative because it's in the north direction. Okay, then he asking about what? He asking about how long will it take, or how long will the pole take to reach to the starting point? To reach to starting point. Okay. So here the speed is equal 0. That's right? Okay. From 0 to negative 8. Okay? How we can get the time? We have the V initial and the V final, and the acceleration is equal negative 9.81. So now we can get the time. So the time delta T is equal V final negative 8, V final minus V initial over acceleration. So delta T equal V final negative 8 minus V initial 0 over acceleration, which is negative 9.81. Okay, cancel this with this. We will get the time. Okay, let's make it very fast. Okay, 8 divided 9.81. So it equal 0.81. Okay, so 0.81 seconds, and this is the time to get from this position to this position, or to the starting point. Yeah. But if he asking about the time of the whole journey during flowing or during throwing it up and then falling down, so here the journey will be doubled, because here the time of falling down, but the time of rising up will be double the time. So the time of the whole journey will be 2 times 0.81, but the falling down will be 0.81 seconds. And that's it. Okay, I hope this revision, inshallah, is useful for you, and I'm gonna make another third video for the solution, or for solving a part of the revision sheet. And okay, pray for me. Thank you.